Hello everyone, welcome to MK Maths. I am Karthik Mansali. In last video, we have discussed about definition of relations and types of relations. I have covered all definitions of relations and types of relations with examples, that too by episode. So if you not watch those previous videos, so you can check my description. I have kept link there, so you can click those links and you can watch my all my previous videos. So, and I have covered 3 marks question from the relations topic also. So from relation topic, from PU board, we may get 3 marks questions. So I have covered those 3 marks questions, that too based on a particular equivalence relation. And also I have covered how to write a 3 marks question when they ask R is not reflexive, not symmetric, not transitive. So those problems also I have covered. So I have made 3 parts there for 3 marks question. I have made 3 parts. Those links also you can check in my description. Uh, Now after completion of that relation and types of relation, next we move to the topic functions. Okay, so functions we have studied already in first PU and second PU. Just I am going to revise for both first PUC and second PUC. So first PU students can also watch this functions topic, because I am just explaining introduction to functions. So for second PU also it will be helpful, because to understand the types of function, first we have to understand the definition of a function. So similarly, how we studied a definition of a relation and a types of relation, now we are going to study a definition of a function and a types of a functions. Okay, so but from this functions topic, in PU board we may get 5 marks. Definitely 5 marks question will be there from this topic. So I am going to solve that 5 marks questions also. And after completion of this relation and functions chapter, next I am going to start a CET problem, so that you will solve the CET problems also between these two topics, relations and functions. Okay, without any wasting time, let's move to our functions topic. So first let's start with the set, because everything is started with the set here. So first we have considered A, B. Okay, first we have considered two sets A and B. A is not empty. In first video which I have discussed in definition of relation, I have mentioned. And B is also not empty, because when we consider two non-empty set, then only all next things can create. Because if two sets are empty, then there is no possible to create a relation between them. So to create a relation between those two sets, definitely there should be elements in A and there should be elements in B. Okay, so by these two sets, we created A cross B. Okay, we created A cross B, and we called that A cross B as Cartesian product. We call this as Cartesian product. Cartesian product from A to B. Cartesian product from A to B. Okay, so next next from this A cross B, we have created a set R, that R is subset of A cross B. So we created a R, that R will be subset of A cross B. Then we called this R is relation. Then we called this is relation from A to B. This is relation from A to B. So it started with sets. So A and B are non-empty sets. So this is a sets concept, and this is a Cartesian product. From Cartesian product to we move to relation. Now next our aim is functions. Okay. So here our functions are nothing but f. We denote the function is f here. This function is nothing but a special type of relation. Special type of relation. So this f is nothing but, now we call that f as a function. Before we call it this function, first the f should be relation. F should be relation. It should satisfy the definition of a relation. It means that f should also subset of A cross B. Okay, so if f is a relation, then if it is satisfy some condition, then we call that f is a function. So here f is nothing but a function, is nothing but a relation itself, because so from relations only we create a function. So here first to create a function, to exist a function, it should become first relation. So after relation exists, then only function will exist. So first, if you want to check the function or not, means first that f should be relation. So that relation has special type here. Special type means it has some extra condition, it should satisfy some condition. So if relation satisfies that condition, we can name that relation as a function. For our convenient, we change that special type of relation as a function. So now onwards we call that type of relation as a function now. So through definition we can understand what is that condition, what made that condition to call a relation as a functions. So let us understand definition of a function, then we are going to understand why we call it as a special type of a relation. So first you should understand, so R is a relation. Okay, if R is a relation, then f is a function. If I want to say f is a function, then f must be relation. First f should be relation. If f is a relation and satisfies some condition, it satisfies some condition, f is a relation and it satisfies some condition, then definitely we call it as a function. Okay, so that if we should call f as a function, means first it should be a relation and it should satisfy that some condition. Let's see that what is that condition. Okay, so let's move to definition part. So here definition of a function. So let's understand the definition of a function. So here relation f, see I have written relation f. So previous video, in previous topic I have mentioning relation R. So in the place of R we have now f. In the place of R we are having now f. Okay, so relation f is said to be function. So f is already a relation. So I am started the definition with a relation f. It means f is already a relation. So that f, relation f, is said to be function. If now I have to say that relation f is function, means function from non-empty sets A to B. We already discussed why we are mentioning non-empty set. Okay, so relation f is said to be function from non-empty set A to B. If we want to say the function, the relation f is a function from A to B, then it should satisfy some condition. I have told previously that a relation should satisfy some condition, then it become a special type. So we named that special type as a function. Okay, so that condition is nothing but every element of A. Every element of A means the relation A is the set which starts the relation. Okay, every element of A means we have to consider each and every element of A has one and only one image in B, as one and only one image in B. So it means every element of A, we have to consider each and element from the set A. Those elements, each and every elements we considered, no, so those elements has one and only one image in B, image means outcomes from the set A. Okay, so if all elements has a one and only one outcome which meets to B, then it is nothing but a function. So every element of A, one condition, and has one and only one image in B, second condition. So relation f is said to be function from a non-empty set A to B, then it has to satisfy here two conditions. First condition is every element of A. So it has to satisfy, it has to use to create a function. So it has to use each and every element of A, and those elements should have one and only one image in B. Let's see this condition through example, so it will be easy to understand. Okay, so if you not understand the definition in sentence, let us try to understand the definition with the help of example, so that it will be easy to grasp the definition. So I have considered the three examples here. So this first circle, first oval shape I have considered, no, so this is nothing but a domain. So first set we call it as a domain. Domain means which is very important to create a relation, which is very important to create something. So in these two sets, A is the very important to start a relation, because every relation starts from one set to another set. So one first set is very important to start a relation, so we call that first set as a domain. Okay, so next, this is codomain, remaining part. If you consider a first set as a domain, next second remaining part will be codomain. Codomain means complement of a domain, so this is codomain. This is codomain. I hope you understood the domain and codomain. Domain is nothing but a first set which is very helpful and very important to create a relation. So and codomain is nothing but after creating a relation, it has to end with some other set, because if it started a relation, there is nothing to end, means it is not possible to create a relation. So to create a relation, there should be a start and there should be end. So starting point, so starting set, we call it as a domain, and the relation where it ends, we call it as a codomain. Okay, codomain. So first, to satisfy the definition of a function, every element of A is there. So every element of A means, if you observe here, one as used, see one as one arrow mark going outside. So don't focus on where it is going. So don't focus on the codomain, because to understand the definition of a function, we have to only focus on the domain. Starting set is the important, where it is a starting, where it is creating, that part is important. Where it is ending, where it is output are going, so it is not important. So it means codomain is not important when we are discussing about the definition of a function. So just to focus on the domain, then it will be easy to understand the definition of function. If we focus on codomain, then it start to confusion, and it feel us to understand the definition very hard. So try to focus only on domain. I also going to explain only domain part, because to understand the definition of function, domain is enough. So now first point here is every element of A. So this condition should satisfy. So every element of A means, see, one having the arrow mark going outside to set B. So I am not focusing where it is going and where it is landing. I am not focusing. The relation is started, that's enough. And second element to 2 I am considering. 2 is also here starting point. 2 is also is there. It also has a arrow mark going outside. I am not focusing on where it is going, so it is not important for us. So and I am focusing on 3. 3 is also element of A, and 3 also having a arrow mark which is going outside. Okay, well and good. So and 4 is also element of A. The 4 has also arrow mark which is going outside. It means 1 2 3 4 we have used each and every element of A. It means the first condition is satisfied. Here first condition is satisfied. So next move to second condition. Every element of A has one and only one image in B. Has one and only one image in B. One and only one image in B means, see, for example, 1 having here image B. So this arrow mark is only 1. So 1 is reaching to B means 1 has only one image in B. Okay, so this B is nothing but a image here. Image means if you stand in front of a mirror, the inside mirror is that person is the image of myself. Okay, image is nothing but a reflection part. If I reflected in a mirror means that reflected part is a image, we call it as. Okay, so here for 1, B is the image. So here one and only one image is there, so only one arrow mark is going outside the 1. So from domain, if you consider a 1, so from 1 there is only one image which is going outside, means from 1 there is creating only one relation. Okay, so if you consider 2, from 2 there is only one arrow mark which is going. It means for 2, element 2 has one and only one image in B. So for 3, if you consider 3, there is only one arrow mark which is going outside A, outside 3. So it means 3 has only one and only one image in B. So if you consider 4 has only one arrow mark which is going outside from A. It means 4 has only one and only one image in B. It means every element of A means 1 2 3 4 are all elements of A are using here, and using with the only one image, so only one arrow marks are there. If you have to observe how many arrow marks are going from each element. So from each element there is only one arrow marks going outside from set A. It means it's satisfying both condition. Every element of A it is satisfying, has one and only one image in B, it is also satisfying. So we can call it this as f is function. This f is function, I call it as f1, f2, f3. So then there will be no confusion for us. Okay, now here f1 is a function because it satisfies two conditions. Every element of A is also satisfied, as one and only one image in B it also satisfied. I hope you understand this example. Let's move to next example now. So I have considered this set A and set B. So I have arrow mark created here. This arrow mark is nothing but relationship. One is related to C. We write ordered pair, no, 1 comma C, 1 comma B. In previous video I already explained this is one of the representation of a relation. So arrow diagram I am using here. So 1 C means 1 is related to C, 2 is arrow mark is going to A means 2 is related to A, 3 arrow mark is going to B means 3 is related to B, like that. Okay, so here first let us check the again condition for f2. Every element of A, okay, so here 1 is using, so 1 has arrow mark, okay, 2 is also used because 2 has arrow mark, 3 is also used because 3 has arrow mark, but 4 there is no arrow mark here. So therefore we have not used 4 because 4 is also element of A, but here 4 is not used. 4 is nothing related to any element in B. So there is no image to B. There is no image in B. So it means 4 is empty here. 4 has nothing relation. 4 we are not using 4 here. So it failed here. So every element of A, that is first condition itself it failed. So directly we can write, there is no need to check one and only one image in B, all those things, because first condition only failed. Every element of A is not satisfying in this given example because 1 is used, 2 is used, 3 is used, but 4 we are not used here. So then f2 is not function. f2 is not function. We can call it as f2 is a not function because first condition itself it failed. So now let's move to the third condition, f3, third example, f3. So I have considered A and B. This is a domain, A is a domain and B is a codomain. Okay, so now, so here first let us check the same first condition, every element of A. Okay, so here 1 is used, okay, well and good, 2 is used, okay, 3 is used because 3 has arrow mark, 1, 2 has arrow mark, 1 also having arrow mark, and 4 also having arrow mark. So first condition is satisfied. So every element of A is satisfied here. So if every element of A is satisfied, then we have to move second condition. We should not conclude here because every element of A satisfied, okay, but two conditions should also satisfy, not one condition here. Every element of A also satisfy and one and only one image in B, this condition should also be satisfied. Then only we can say or we can conclude the given f is a function. Okay, so next mode, every element of A is okay, all it satisfied because 1, 2, 3, 4 are used in set A. So now has one and only one image in B. The next question is one and only one image in B they have asked. So let's see there is one and only one image or not. So from A, if we start with A1, so here 1 having 2 arrow marks, so that is the problem. So here one having the arrow mark towards A and one having the arrow mark towards D. So here we are having two arrow marks which is going from A, which is not satisfying one and only one image. It has a two image, one has a two image, A and D. A and D are the two images to one. It means second condition is failed. So in the second example, first condition is failed, so it is not a function. In third example, first condition is satisfied, but second condition is failed. One and only one image is not there here. For one, there are two images. If element of A contains two images, then directly we can write this f3 can write this f3 is not function. F3 is not function. I hope you understood these three examples. So to to call it as a function, to say it f given f is a function, it has to satisfy two condition, then only we can say it is a function. If in between two condition, if one condition is failed, then directly we can conclude it is not a function. Okay, so in the second example, first condition has failed, every element of a is not satisfying here because 4 is not used, so it is not a function. In third example, one and only one image in b, second condition is failed, so it is not a function. So to say not a function, there are two possibilities: either it should fail every element of a. If every element of a is not used, then directly we can say given f is not a function. Another way to say not function means, another way to say not function here is, so one and only one image, if you not got one and only one image, then directly you can say it is not function. Here for example, third example, one having a two images a and d. So if you are getting a two images more than one image, so then definitely you can say it is not a function. So I hope you understood the definition of a function. If you understood the definition of a function, then definitely you are going to understand next upcoming types of functions. So in next video I am going to explain about types of function in one by one in detailed way. So please watch those videos to get you will get, definitely you will understand more, and you will definitely easily to solve more problems in that part also, in function part also. So if you understand relation and function easily, then KCT problems will also easy, because it all depends upon definition game. If you are own in the definition game, if you understand very well in this definition, then you can easily play a game, KCT game. Okay, so these three examples are very important, so just observe these three examples, and if you want to create a more example, you can create and try trial and error method, and create yourself more examples so that you will understand easily. Okay, so if you watch my video, so please subscribe to my video and also share to others who are needed, and who are to your friends and family, so that it reach larger audience. And like if you like my video, then I will get a motivation to do more videos. So let us all meet in next video. I am going to explain in that video types of functions. Okay, types of functions, that too one by one. Okay, bye.